In this video, we are going to discuss hybridization in molecules having double bond and triple bond. So first of all, we are going to discuss the example of ethene molecule. Ethene is an example of alkyne. So first of all, draw the skeletal structure for ethene. There is carbon-carbon double bond, and each carbon is bonded with two hydrogens. And as you know, single bond is formed by sigma bonds. So there is sigma bond present between carbon and hydrogen. And double bond is formed by one of sigma and one of pi bond. So in this way, each carbon is bonded with 3 sigma and 1 pi bond. As we have discussed, hybridization is applicable to the central atom only. And there are two center atoms, carbon 1 and carbon 2. So first of all, write the ground state configuration for carbon. It will be 1s2, 2s2, 2p2. When you fill electrons, you will get 2 electrons in 2s and 2 electrons in 2p. And here you can see there are 2 half-filled atomic orbitals. But we need to form 4 bonds. For the formation of 4 bonds, we will require 4 half-filled atomic orbitals. For that, we need to promote one of the electron from 2s to 2p. And you will get excited state configuration 1s2, 2s1, 2p3. And when you fill electrons in it, you will get 4 half-filled atomic orbitals. And as we have discussed earlier, hybridized orbitals participate in the formation of sigma bond only. So for the formation of 3 sigma bonds, we will require 3 hybridized orbitals. For that, we need to hybridize 3 of the orbitals. 1 from S and 2 from P. So you will get 3 sp2 hybridized orbital. And this pz orbital, that is unhybridized, will be used for the formation of pi bond. Now these 3 sp2 hybridized orbitals arrange themselves in trigonal planar geometry to minimize the repulsion between them. This is carbon 1 and this is carbon 2. And these are the sp2 hybridized orbitals of each carbon arranged in trigonal planar geometry. So let's see how carbon-carbon sigma bond is formed. For the formation of sigma bond, one of the sp2 hybridized orbital of each carbon overlap head-on and form sigma bond. So this sigma bond is formed by the overlapping of sp2 hybridized orbital and sp2 hybridized orbital of another carbon. Now the formation of sigma bond with carbon and hydrogen. This sigma bond is formed by the overlapping of sp2 hybridized orbital of carbon and s orbital of hydrogen. So that's how carbon-hydrogen sigma bonds are formed. Now come to see how pi bond is formed between two carbons. For the formation of pi bond, we are going to use unhybridized pz orbital. This pz orbital is perpendicular to the plane and each pz orbital contains single electron. As they are parallel to each other, they can do sidewise overlapping. And by the sidewise overlapping, they result in the formation of pi bond. This pi bond is perpendicular to the plane and it contains 2 electron clouds, one above and one below to the internuclear axis. When you see the geometry of ethyne molecule, you will see all sigma bonds present in a plane and pi bond is present above and below to the internuclear axis in the form of electron clouds. Now come to see the hybridization of ethyne. First of all, draw the skeletal structure for ethyne. Ethyne is an example of alkyne. So it contains carbon-carbon triple bond and each carbon is bonded with one hydrogen. And as you know, single bond is formed by the sigma bond and triple bond is formed by 1 sigma and 2 pi bonds. So here each carbon is bonded with 2 sigma bond and 2 pi bonds. And as we have discussed, hybridization is applicable to the central atom only. And as there are 2 carbon centers, carbon 1 and carbon 2, we have to write the ground state configuration for carbon. And it will be 1s2, 2s2, 2p. So here you will get 2 electrons in 2s and 2 electrons in 2p. But for the formation of 4 bonds, we will require 4 half-filled atomic orbitals. But here you will get only 2 half-filled atomic orbitals. To get 4, we need to promote one of the electron from 2s to 2p. So you will get excited state configuration 1s2, 2s1, 2p, 3. So now we will have 4 half-filled atomic orbitals. And as we have discussed earlier, for the formation of sigma bond, we need hybridized orbital. For the formation of two hybridized orbital, we have to hybridize one of s and one of p, and as a result, you will get two sp hybridized orbitals. And these two unhybridized py and pz atomic orbital, we are going to use them for the formation of pi bond. Now these two sp hybridized orbital arrange themselves in linear geometry to minimize the repulsion between them. These are the sp hybridized orbitals of each carbon. Now see how sigma bond is formed between two carbons. Sigma bond is formed by the overlapping of sp hybridized orbital of each carbon. So this sigma bond is formed by the overlapping of sp hybridized orbitals of each carbon. And carbon-hydrogen sigma bond is formed by the overlapping of sp hybridized orbital and s orbital of hydrogen. So that's how carbon-hydrogen sigma bond is formed. Now let's see how carbon-carbon pi bonds are formed. For the formation of pi bonds, we are going to use unhybridized py and pz atomic orbitals. As they are two unhybridized orbitals, we will get two pi bonds. These are two py atomic orbital of each carbon. They both perpendicular to the plane, but they are parallel to each other and they both contain single electron. So by the sidewise overlapping, they result in the formation of first pi bond. And the second pi bond is formed by the overlapping of pz atomic orbitals of both carbon. These pz atomic orbitals are also parallel to each other and perpendicular to the plane. They both contain single electron. So they can do sidewise overlapping and result in the formation of second pi bond. When you see the geometry of ethyne molecule, you will see all sigma bonds present in the plane and pi bonds present in the form of electron clouds above and below to the internuclear axis. Now compare between single bond, double bond and triple bond. Single bond is formed by the sigma bond. Double bond is formed by one of sigma and one of pi, while triple bond is formed by one sigma and two pi bonds. That's why triple bond is the shortest among them and single bond is longest among them. Bond strength is inversely proportional to the bond length. That's why longest sigma bond will be the weakest one and shortest triple bond will be the strongest one.